China is planning to put a moon of its own in the sky. Chengdu city in southwestern Sichuan province of China is developing illumination satellites which will shine along with the real moon but will be 8 times brighter than the real one.
A headline like this spreads fast. China is building a second moon in the sky. It sounds like science fiction, but it's based on a real idea. A reflective satellite that bounces sunlight down to Earth at night like a giant mirror in orbit. And the biggest question isn't can they do it, it's should anyone do it at all? The story people remember is simple: light up a city from space to save electricity. But the reality is messier. Even early reports framed it as a proposal tied to Chengdu, not a literal new moon, more like a space-based streetlight helper. And once you dig in, you find a twist. The light might be too weak to replace streetlights anyway. So why talk about it like a second moon? Because moonlight is the perfect emotional target. The moon feels natural, peaceful, harmless. If you can say, we're just adding moonlight, it sounds gentle. But what most people miss is that adding light to the night is never neutral. Here's the big question we're going to answer. If a country can turn on the night from orbit, who gets to control the switch? And what happens to everyone under that sky, humans, animals, and telescopes, when the night is no longer truly dark? The most cited plan described a satellite in low Earth orbit, around 500 kilometers up, with a reflective surface that could aim sunlight down toward a city. Some reports said it could be up to 8 times brighter than moonlight and cover a large area on the ground. It was framed as a way to reduce streetlight use and save money. Some coverage added details that sound very engineer-like, claims about controlling where the light lands, testing in remote areas first, and even launching multiple satellites for more coverage. But notice the careful wording. It was often described as supplementing lights, not replacing all of them. That one word, supplement, changes everything. And there's a reason. The second moon image sounds huge, but the engineering is fighting basic physics. So let's do the part most viral posts never do, the brightness reality check. Start with a simple number. Full moonlight is dim. Many references put full moon illuminance around 0.1 to 0.3 lux on the ground, depending on conditions. That's enough for your eyes to adjust, but it's nowhere near streetlight bright. Now compare that to typical street lighting. A roadway or street environment is usually measured in multiple lux, not fractions of a lux. In other words, streetlights are often tens of times brighter than moonlight. So what happens if you make an artificial moon 8 times brighter than moonlight? 8 times a small number is still a small number. Even some reports about the plan said the light would be about 1/5 as bright as a streetlight. That's not turn night into day, that's more like a soft glow. This is the first big you think X but Y moment. You think a mirror in space replaces streetlights, but the numbers push you toward a mirror in space might make the night slightly less dark for a short time in a limited place. Here's the second big twist. Satellites don't hover. In low Earth orbit, satellites move extremely fast, around 7.8 kilometers per second, and circle Earth roughly every 90 minutes. That means the ground below is constantly changing, so keeping a bright spotlight parked over one city is not simple. This is why experts looking at the Chengdu artificial moon idea said it probably wouldn't work as advertised. A satellite low enough to deliver meaningful brightness can't just stay above one place without special orbits, constant adjustments, or lots of satellites working together. So the second moon starts to look less like one object and more like a system. And if the solution is use more satellites, you open a new set of problems. More objects in orbit means more crowding, more tracking, and more chances for interference with other space activity. The sky isn't an empty billboard, it's a shared space. So now we're at the heart of the story. This isn't just China building a second moon. It's the bigger question. Should humanity treat orbit like a place to install giant lamps? Let's be fair, the motivation isn't hard to understand. Lighting uses a lot of electricity globally. Major climate and energy programs said electricity for lighting is about 15% of global power consumption and around 5% of global greenhouse gas emissions. So cutting lighting demand is a real goal. Zoom in from the world to a city, and it gets even more tempting. Public street and area lighting can be a massive municipal expense. Some programs say it can be up to 40% of a municipality's electricity use, and about 1 to 3% of total electricity demand worldwide for street lighting. If you're a city leader, cheaper lighting sounds like a win. That's why the second moon idea keeps coming back in different countries and different decades. Not always as a serious plan to replace lights, sometimes as an emergency backup, a tech demo, or a prestige project. But every version runs into the same question: what's the hidden cost of brighter nights? Light pollution isn't just seeing fewer stars. It's the human-made brightening of the night through glare, sky glow, light trespass, and clutter. And it affects wildlife, ecosystems, human health, energy, and culture. Here's the scary part. Even without any artificial moon, the world is already getting brighter at night. A major satellite-based study found Earth's lit outdoor area and brightness increased by about 2.2% per year from 2012 to 2016. That sounds small until you realize it compounds year after year. And some newer work suggests the situation can look even worse from the ground, because some satellites don't fully see certain kinds of blue-rich LED light the way humans do. So the sky can feel like it's brightening faster than the simplest space measurements suggest. Now add the second moon idea into that reality. Even if the beam is only moonlight level, it's still extra light placed where nature didn't put it. And for many species, small changes at night are a big deal. Birds, sea turtles, insects, and many nocturnal animals use natural darkness like a map and a clock. Artificial light at night can change movement, feeding, and migration patterns, sometimes pulling animals toward danger. This is why scientists treat night lighting as a serious environmental factor, not just a pretty city problem. What about humans? Research on light at night often focuses on how light can shift circadian rhythms, your body's internal day-night schedule. The details depend on brightness, timing, and color, and scientists don't claim every small exposure is the same. But it's enough of a concern that it's studied deeply in health research. So when people say catastrophic light pollution, the fear isn't that a city becomes a white blur overnight. The fear is slower. Darkness becomes rare, ecosystems get stressed, and the night sky becomes something you have to travel to see. And once you normalize lights in orbit, you may never go back. Astronomers are already dealing with bright objects in orbit. Large satellite constellations can leave streaks in images, raise the background brightness, and interfere with observations, especially at dawn and dusk. That's not a theory, it's happening now. This is why major astronomy groups helped create coordination centers and workshops focused on protecting dark skies. The point is simple. Once the sky is crowded and bright, science loses part of its window to the universe. And it's not only professional scientists. These discussions also include impacts on astrophotography, amateur astronomy, and the human experience of seeing the Milky Way. In plain words, it's about data, and it's about heritage. Now connect the dots. If regular communication satellites already create problems, a purpose-built reflective moonlight satellite could be even more disruptive if it's designed to be bright in the visible sky. That's why astronomers react strongly to anything that adds deliberate light overhead. Even if one city wants it, the light doesn't stop at the city border. Sky glow spreads, light reflects off clouds, the atmosphere scatters it. So a decision made locally can still change the night for people far away. And that leads to the hardest question. Who has the right to brighten the sky for everyone? Space is used by many nations, many companies, and many scientists. That's why international groups are pushing for shared norms and mitigation before the sky becomes unmanageable. This isn't anti-tech, it's risk management. The goal is coordination between astronomers, industry, and policymakers because the alternative is chaos. So the second moon question becomes a global governance question. If orbit becomes a place for lighting systems, does every country get a vote? And what happens when two groups want different skies, one brighter for business, one darker for science? Here's the punchline many people don't expect. If your goal is to save energy and improve night safety, you don't need a moon in space. You can often get big savings by fixing waste, shielding lights, using warmer color temperatures, adding sensors, and dimming when streets are empty. Global programs have pushed efficient lighting for years because it's one of the fastest wins. Organizations tied to climate action have argued efficient lighting can cut emissions significantly, and it's often cheaper than building new power supply. That's real, scalable, and doesn't require orbiting mirrors. And for cities, street lighting upgrades can be huge. Public street and area lighting can be a big slice of municipal power use, and efficient street lighting is a well-known way to reduce costs and emissions. The key difference, you can do it while also reducing sky glow if you design it right. So why does the second moon idea keep pulling attention? Because it's dramatic, it's a headline machine. And sometimes big projects are as much about signaling power and innovation as they are about solving the most practical version of a problem. So, is China building a second moon? The honest answer is, reports describe an illumination satellite concept, a reflective system meant to cast additional light tied to city-level goals like saving electricity. It's not a new natural moon, it's a human-made light source. Could something like this exist one day? Physics doesn't forbid reflecting sunlight, but the practical hurdles, brightness, targeting, time over a city, and orbital constraints are why experts were skeptical about the strongest claims. And even if the engineering works, the real battle is the one on the ground. Do we treat night as a resource worth protecting? Because once the night becomes another space for industry, another place to optimize, we may lose something we can't easily rebuild. So the second moon story isn't really about China. It's about what happens when technology makes it possible to edit the sky itself. The next chapter won't be written by one launch. It'll be written by rules, norms, and choices the world makes together.